Hi there. In this third video, we are going to be setting up our motors and sensors for our dragster robot in RobotC. And so we can quickly get into this by clicking on the motor and sensor setup button here on the ribbon. And when we do that, if this is a new date, go through that process first of making sure that you're using the correct Cortex. So the VEX Cortex 2.0 and the correct language as well, which is the natural language PLTW. But again, when you get here, it's pretty quick to do this. So we're going to go into the motor tab here, and we're going to use motors on ports 1 and 10 of the Cortex. And so we're going to call port 1 right motor, and we capitalize the M here, motor, and we don't put spaces because this needs to be a string of characters. And if we're using two words to describe this variable, right motor, or the sing right motor, it's easiest to read those words by capitalizing the first letter of any words after our first word. So we'll call that right motor. On port 10, we're going to call that motor left motor. And we're going to use the motor type 269, so VEX 269 motor. For both of these, you will have the option to do a 393 motor as well, but our test beds just have 269 motors on them. And when it comes time to do the dragster, you'll have to figure out which motor will work best for what you're trying to do. The other thing we have to do is set up the digital sensor. So there's an analog sensor tab here, but we are not necessarily going to be using analog sensors. There have been some students in the past that have used basically line following sensors or light detecting sensors to detect basically our finish line and then have the robot come to a stop. But that would be more on the exceeds end of the thing. And so since we're doing some pretty basic programming at this point, we're going to avoid that at this point and maybe come back to it later for some of you. We're going to go into VEX Cortex digital sensors, and we're going to set up a digital sensor, and we'll just call it the go button. And this will be a touch sensor that we'll use to start our dragster on the starting line. And we will hit OK. And when we do that, we're going to get some code on lines 1, 2, and 3. This hashtag pragma basically says, hey, robot, we're going to configure on line 1 anyways, a sensor, and on lines 2 and 3, they are going to be configuring motors. For line 1, the sensor is on digital 1, called the go button, and will be a touch sensor. For our motors, they're going to be on ports 1 and 10, called right and left motor, and they will be a 269 motor for each of them. Alright, so we need to go down to our code now within task main, and we have to change some of these things which say sensor port and motor port. And so our sensor port, we called our sensor the go button. And so we're going to type go button there. For our motor port, we're going to call this the right motor, and the left motor. And for stopping our motors, we're going to stop the right motor and the left motor. Okay, so our motors run at a speed value, which for our purposes will be a range of 1 to 100. Now you might actually want to do some research to see if this is actually the maximum speed of our motor. I'm not 100% sure on that. Okay, so anyways, we're going to go for max speed here on the dragster, so we're going to set the value here to 100, and the rest of our code should be good. And so we're going to compile the program by hitting this button here, and it's going to ask us to save it. I'm going to save it on my desktop because I'm actively working on it. I may move it to my document folder, but I'll call it the dragster code, and hit save. And no errors down here in the compiler, so that's good. I've done this plenty of times though, and so, I know what to do not to generate errors. Just for fun, I'm going to put a few errors in here so you can see what it might look like. So I'm going to take away this semicolon here. I'm going to take away a comma here. I'm going to call this capital left motor. And For the weight, I may delete this W here. And for the stop motor, I may change the motor to an E here. And just for fun, I may say stop mother. And we're going to compile it again and see what happens. So we get a lot of errors. And the nice thing about the compiler here, we can go through and see what these errors might be. So on line 22, it says we're missing a semicolon, and that it automatically inserted into it by the compiler. And so that's nice, but let's fix it. And on line 23, it says missing a parenthesis, missing unmatched left parenthesis. And so what this is looking for is this comma. Because I think you can start a motor without a speed value. I could be wrong on that. And so it's waiting for that parenthesis. But actually it's a comma missing. On line 23, it is also expecting a few other things. So fixing that comma should fix that issue there of it looking for a bunch of things. On line 24, it substituted a lowercase left for the uppercase I had changed, and so I'll fix that. It does not understand this procedure 8, and so we're going to switch that to wait on line 25. On line 26, it does not understand this variable motor with an E, so I don't know there. And there is going to be an undefined procedure stop motor on line 27. It should be motor. And so we'll compile again, and our errors are gone. So use that compiler to find errors, see if you can figure out what the issue seems to be based off of what it's telling you down there. And if not, just invite me over and we'll look at your code and hopefully help you figure out what your issue seems to be. So we'll save it, and now we have something to use on our test bed.